Hello, my name is Chris Pritchard, and I'm going to be speaking to you today about statistical diagrams from William Playfair to Florence Nightingale. This is part of the programme called Lumen, Loughborough University Mathematics Education Network. You'll see my email address at the bottom of this slide, chrispritchard2@aol.com. And it will also appear on the final slide. And I would be pleased to hear from you after the talk if you would like any further information or would like to share ideas, then please get in touch. So let me give you the big picture. And this is a big picture. Statistical graphs and charts are seen daily on our computers and tablets, on TV and in newspapers, magazines and journals. And of course, as maths teachers, we meet them frequently in our lessons. This talk is about statistical diagrams and their history and their teaching. The earliest statistical diagrams were drawn towards the end of the 18th century by William Playfair. Which diagrams did he invent and why? Where did his ideas come from and how successfully did he execute them? Further development of Playfair's diagrams took place mainly in France, especially in the hands of Charles-Joseph Minard. His diagrams, Minard's diagrams, are among the most inventive and most dramatic ever produced. Playfair's diagrams were less well received in Britain, but this changed through the influence of William Farr. Florence Nightingale then extended them further for the purpose of persuading the Westminster government to institute changes in nursing practices that not only saved British soldiers in the Crimean War, but endure to this day. Let me tell you a little bit about William Playfair, the man. Well, he features here because he was the father of statistical diagrams, and in particular, the time series chart. And you see a fine example of a time series chart on the screen at the moment. But also the bar chart, the circle chart, and the pie chart with a variant, which we might call an annulus chart or a concentric circle chart. William Playfair was born in 1759 in a small village called Benvie, just outside Dundee. His father died relatively young. We have no image of William Playfair. There are plenty of images, purportedly, images of him on the internet, but none, in fact, are images of William Playfair. William Playfair was the younger brother of the very famous mathematician and geologist John Playfair, who produced a famous edition of Euclid's Elements in 1795, in which the fifth axiom was given in the form that we know it today. Here we see John Playfair, Esquire, FRS, Professor of Natural Philosophy in the University of Edinburgh, and his book, Elements of Geometry, the first 6 books of Euclid. And there's that quote, the definition of the fifth axiom: through any point in the plane, there is at most one straight line parallel to a given straight line. That's now known as Playfair's axiom. I said already that William and John's father died fairly young, and so it was that John was partly responsible for William's education. William Playfair was also the uncle of the architect, William Henry Playfair, who designed a number of striking buildings in Edinburgh's new town. This is William Henry Playfair. And I'll show you just two of his buildings. In fact, the first is in the new town, the second is in the old town. But the preponderance of buildings are in the new town. The first of these is the National Gallery of Scotland, which lies on Princes Street. For those of you that know Edinburgh well, Princes Street is a one-sided street with gardens down one side, and the National Gallery of Scotland sits in those gardens. And this is the Playfair Library, the old college, in the University of Edinburgh. Splendid building with barrel vaulting. In early adulthood, Playfair, and now I mean William Playfair, the statistical genius, he was taken on by a local millwright as an apprentice draftsman. He'd always been good drawing, and this seemed like a sensible move for him. But he soon moved to the Soho manufactory in Birmingham to work for Matthew Boulton and James Watt. This was a very, very famous, or became a very, very famous manufacturing site in Birmingham, and certainly Matthew Boulton and James Watt were huge figures. For the Soho manufactory, Playfair installed steam-powered machinery at the top of mine shafts. But he didn't stay very long. He broke with the company. He thought they weren't adventurous enough, not enough research and development. And so he decided to start his own companies. There were two companies, and he took out a number of patents as well. And then his focus moved again. This time, he started to take an interest in international business and economics. And so it was that he moved to Paris to do business there and gave a first-hand account of the French Revolution. We don't know whether he took part in the storming of the Bastille. There is no record that he did, but he did attend a meeting of the insurgents the previous evening, and that is recorded. But then Playfair became engaged in some shadier business, which tarnished his reputation in Britain. There were a number of people who had plenty of money during the time of the French Revolution and wanted to get out of the country. So where best to go than the newly free and established America? So William Playfair sold plots of land to these people fleeing from Paris. But when they got to the States, they found that William Playfair didn't own the deeds to these pieces of land. And so they'd arrived over several thousand miles of sea, only to find they had nowhere to construct their new buildings. He also fell in with the British government establishment in Westminster, and they persuaded him to become involved as a British agent. This is spying work, but before spying was organized. The activity he engaged in was finding out how the French semaphore system worked. It had just been devised to send messages rapidly from Paris to the coast, Boulogne and around there. And having worked out how they did it, he passed that information back to the British government. He also designed a plan to flood the French economy with fake paper money called assignats, the plan being that this would quite likely bring down the French economy. On a personal level, he was often in financial trouble, and he was incarcerated in the Fleet, which is a debtor's prison near Fleet Street in London. But William Playfair, for all his faults, did produce the world's first statistical diagrams. And the time series chart and the dual bar chart were the first two of these to be designed, and they appeared in the Commercial and Political Atlas in 1786. Now you might wonder, to what extent did William Playfair understand what he was trying to do, the ideas he was trying to incorporate, his feeling for what was going on in his work? So let me quote from the Political Atlas. Information, he said, that is imperfectly acquired is generally as imperfectly retained, and a man who has carefully investigated a printed table finds, when done, that he has only a very faint and partial idea of what he has read, and that, like a figure imprinted on sand, is soon totally erased and defaced. These charts give a simple and distinct idea. They are as near perfect accuracy as is anyway useful. On inspecting any one of these charts attentively, a sufficiently distinct impression will be made to remain unimpaired for a considerable time, and the idea which does remain will be simple and complete. Playfair's diagram of choice was the time series chart. In fact, all but one of the 44 charts in his first book, The Commercial and Political Atlas, are time series charts. Examples include a depiction of the fluctuating balance of trade between England and its trading partners, a comparison of revenues of England and France since 1550, changes in the national debt over time, and expenditure on the armed forces and ordnance. The relationships they show are not functional relationships, but a trace of empirical data over time. And this must be understood to be a complete departure from what had gone before. This is the very first of those time series charts, a chart of all the imports and exports to and from England from the year 1700 to 1782 by W. Playfair. What I'd like you to do is to have a little look at this time series chart and think about the way that you teach statistical diagrams in your classes today, and try and make some judgments about just how good this chart is. What does it have? What features does it have? Is it missing any? Would you teach it differently? It certainly has axes with explanatory labels underneath. It says at the bottom, the divisions at the bottom express years, and those on the right hand, millions of pounds. So time is on the horizontal axis, absolutely typical today, and the revenues are on the right-hand side, on the vertical scale. There's a uniform graduation of the axes, and the units are indicated. Time progresses in 10-year blocks. Millions of pounds progress upwards 1 unit at a time. Complete uniformity. There is a title and a frame. The lines, the key lines, are labelled exports on the top and imports underneath. There are grid lines for ease in estimating values. If you need to interpolate, then you have a fair idea of the sort of values you'll be seeking. There is colour to bring out salient details. So this first statistical diagram came fully grown, not in need of further development. This is essentially everything we teach should be included today in our classrooms. The data available to William Playfair were very extensive indeed as far as England was concerned, and consequently a series of time series charts worked very well indeed. But when it came to Scotland, and he wanted to do exactly the same with Scotland and portray what was happening there in a similar manner. But now he had only one set of data. He had the exports and imports of Scotland for 1 year only, from Christmas 1780 to Christmas 1781. So what he does is he takes a snapshot, cutting at right angles what the time series chart might have done, getting a snapshot for 1 year. It's a dual bar chart. You can see the imports and exports colored differently. There are tiny amounts of trade with Jersey, but more interestingly, the bottom end, and he has put these in order of size, which is also a key feature. A lot of trade with Ireland and with Russia. I think that was Catherine the Great's Russia, and a certain amount with America. But the point I'm getting across here is this, that the bar chart was produced by William Playfair as a fallback position because he did not have sufficient data to produce a time series chart. And he knew that there was a problem here. This chart does not comprehend any portion of time and is much inferior in utility to those that do. A bar chart is an inferior statistical diagram. There's a lot of interest in the original diagrams that William Playfair produced. There is a project at the moment called the Recreating Playfair Project at the Digital Humanities Lab at Georgia Institute of Technology. Here we see one of the original diagrams that William Playfair produced. And here it is its modern day version, rather beautifully put together. And yet, with the handwriting sort of style down the right-hand side and with the other labeling. Beautiful piece of work. But Playfair's original diagrams are very highly thought of today, and further work is being done on them. Let's now go to Playfair's second book. I was saying earlier that Playfair spent time in the debtor's prison, the Fleet, and while he was there in 1800, 1801, again with insufficient money to pay his debts, he wrote the Statistical Breviary. It's a strange setup, but it was the case in those days that you were allowed to spend some time out of the debtor's prison. You could come in and out to some extent. You could work to some extent. And he took the time, some of the time that he was in the debtor's prison, to produce the Statistical Breviary of 1801. And here, for the first time, we found the circle chart, the pie chart, and the annular chart. The book consists of 64 pages, with page after page of data on a range of European countries compiled by an academic in Königsberg. I have a copy, a facsimile copy, and this is a photograph of 2 of the pages. showing some information about the Turkish Empire. The book has just 4 plates in it, designed by Playfair, the most famous of which features the statistical chart showing the extent, the population and revenues of the principal nations of Europe in the order of their magnitude. And here it is. And I'll let that one sink in for a little while. Well, you've got it full size on your screen. Again, try to think about what features it has and how does this compare with other similar sort of diagrams that we might produce today. Notice that there are a number of countries, starting with the Russian Empire on the left, and then the Turkish, and Sweden, and the German Empire, and so on. And the circles are getting smaller in size. These outer circles are proportional to area. And my apologies, these circles are proportional to population. And I shall start that again. These circles are proportional to area. And over on the right-hand side, the 6th to the right, 6th from the right, is Britain and Ireland. Slightly smaller version here. Let's have a look at some of the features. So the circles, as I said, eventually have areas proportional to the areas of the country. And so this makes a comparison of the areas easier. They're in order of size. We saw this approach previously with the dual bar chart. So we have the largest of them down to the smallest of them. 2 of the circles are subdivided. Russia on the extreme left and Turkey. And they're subdivided to show their domains in different or on different continents. Critically, these subdivisions are fundamentally different. An annulus in the first case and a sector in the second. Why should this be the case? There are vertical sticks to show population and national budgets, read on scales to the left and right of each circle. And a sloping line to join them, mistakenly thought by Playfair to indicate the burden of taxation on the individual in each of the countries. He was of the view that in Britain, the people were overtaxed. And if you look at that representation, the circle, 6th from the right for Britain, and have a look at the slope of the line joining the top of the 2 sticks, you'll see that it's very steep, a positive gradient and very steep. And he believed that was an indication of the extent to which the British people were taxed, perhaps overtaxed. Soon after the first charts came out, in the Statistical Breviary, there was a French translation. And included in the French translation was a statistical chart of Hindustan and Durrani. Durrani is not mentioned on there. Durrani is effectively Afghanistan today. Apologies for missing the H there. So this is a statistical chart of Hindustan. That is the land of the Hindus. And also the possessions of Zaman Shah. That says Shah, it's written here as Shah, but he was in charge of the Durrani Empire in Afghanistan. And what I wanted to point out again here is, well, it's the region of Bengal split into 2 states, now called Bihar and Odisha, here written as Baha and Orissa. And you'll see that we have once more a subdivision using an annular technique. That is a circle with a wrapped around belt. I've taken this particular diagram and blown it up, then dropped it into Geometer's Sketchpad and taken some measurements. If we take the radius OA and the radius OB, so clearly OB is the greater. If we take the ratio of those, we get 1.47. So the area ratio, that is the annulus to the central circle, is 1.161 to 1. I'm probably giving a little bit too much accuracy there, bearing on the quality of my diagram. But it's not far out. And this is equivalent to having a pie chart with sector angles of 193 degrees and 167 degrees. Now we've seen two examples of William Playfair subdividing a circle in two. In each case, he uses an annulus. He does not use a sector diagram, a pie chart. Only when there were three subdivisions did he give a pie chart version. So my argument here is that his preference, if at all possible, was to use an annulus. And if that is the case, it's clearly not a good idea, because looking at this Bengal annulus, it's not at all clear which of these two domains is the greater. And yet, if you were to use a pie chart instead, it would be absolutely clear. 193 degrees is a fair way from halfway at 180. It would be clear indeed. I wanted to say a bit more about the influence of John Playfair on William. Where did William Playfair's inspiration for his lineal arithmetic, as he called it, come from? Perhaps it was from working at Bolton and Watt, where there were automated pressure recordings produced by the machines. But more likely it's from his brother John. And in fact, in a book of 1805, William Playfair wrote, "I think it well to embrace this opportunity of making some return, as far as acknowledgement is a return, for an obligation of a nature never to be repaid, by acknowledging publicly that, to the best and most affectionate of brothers, I owe the invention of those charts." At a very early period of my life, my brother, who in a most exemplary manner maintained and educated the family his father left, made me keep a register of a thermometer, expressing the variations by lines on a divided scale. He taught me to know that whatever can be expressed in numbers may be represented by lines. The chart of the thermometer was on the same principle with those given here. The application only is different. The brother to whom I owe this now fills the natural philosophy chair in the University of Edinburgh. I wanted to look in some detail at Playfair's understanding of the advantages of statistical diagrams. We've got to remember what a pioneer William Playfair was. This sort of thing had never been done before. So he's got a public out there that he needs to persuade. In total, he produced 177 statistical diagrams, and they were published in 3 clusters over 36 years, starting with predominantly time series charts, then charts based on circles and their parts, and finally a return to time series. The advantages of using them fall under 4 headings in his own words: speed of interpretation and attractiveness of learning, ease of interpretation, not quite the same thing, appeal to the eye, and increased efficiency of learning. And in more detail, as far as the first of these is concerned, speed of interpretation and the attractiveness of learning, in his first book, on page 4, he wrote, "Men of great rank or active business, can only pay attention to general outlines, nor is attention to particulars of use, any farther than they give a general information. With the assistance of these charts, such information will be got without the fatigue and trouble of studying the particulars of which it is composed. No study is less alluring or more dry and tedious than statistics, unless the mind and imagination are set free to work. This from the breviary, his second book. And for ease of interpretation, from the atlas, information that is imperfectly acquired is generally as imperfectly retained, and a man who has carefully investigated a printed table finds, when done, that he has only a very faint and partial idea of what he has read, and that, like a figure imprinted on sand, is soon totally erased and defaced. The amount of mercantile transactions in money and of profit or loss are capable of being as easily represented in drawing as any part of space, or as the face of a country, though till now it has not been attempted. On that principle, these charts were made, and while they give a simple and distinct idea, they are as near perfect accuracy as is anyway useful. On inspecting any one of these charts attentively, a sufficiently distinct impression will be made to remain unimpaired for a considerable time, and the idea which does remain will be simple and complete, at once including the duration and amount. I'm aware that I've repeated some of the argument there to give the fuller picture. Appeal to the eye. As the eye is the best judge of proportion, being able to estimate it with more quickness and accuracy than any other of our organs, it follows that wherever relative quantities are in question, a gradual increase or decrease of any revenue, receipt, or expenditure of money, or other value is to be stated. This mode of representation, it is particularly applicable. It gives a simple, accurate, and permanent idea by giving form and shape to a number of separate ideas, which are otherwise abstract and unconnected. Making an appeal to the eye when proportion and magnitude are concerned is the best and readiest method of conveying a distinct idea. And on increased efficiency of learning. Whatever presents itself quickly and clearly to the mind sets it to work, to reason and think. Whereas it often happens that in learning a number of detached facts, the mind is merely passive and makes no effort further than an attempt to retain such knowledge. The advantages proposed by this mode of representation are to facilitate the attainment of information and aid the memory in retaining it, which 2 points from the principal business in what we call learning or the acquisition of knowledge. That's all I have to say on Playfair, although I'll be giving references later on. Playfair's work was immediately taken up in France. He gave a copy of his first book to the French king, who thought it was wonderful. And there was always a feeling in France that there was something to be developed further, perhaps in a way that wasn't the case in Britain. So in Britain, Playfair did not enjoy a good reputation in his lifetime or since: debt, fraud, imprisonment, and espionage. His Dictionary of National Biography entry, written by John Alger, paints Playfair as a rogue and makes no mention of his statistical diagrams. That is truly amazing. But in France, his reputation was assured when, as I say, King Louis XVI received a copy of the Atlas. Louis, as Playfair later wrote, at once understood the chart and was highly pleased. He said they spoke all languages and were very clear and easily understood. When Playfair died in 1823, following the amputation of a gangrenous leg, the development of statistical diagrams occurred with greater enthusiasm in France than in Britain. And that was no more so to no greater extent than in the writings of Charles Joseph Minard, who was born in 1781, had a long life. Here he is, in all his splendor. Minard was educated at the École Polytechnique, where he came into contact with Lagrange and Fourier, and then he studied engineering. He worked on civil engineering projects on dams, canals, and bridges, rising to become France's Inspector General of Bridges and Roads. But he had a lifelong interest in political economy. Though he did not produce any of his 51 statistical diagrams until the last decade of his career. And even in his day, he was dubbed the Playfair of France. A colleague of Minard's wrote of his work, among his favorite studies, I will cite especially his figurative maps and his graphic tables, the use of which he popularized and to which he attached a well-merited importance. Because for the dry and complicated columns of statistical data, of which the analysis and discussion always require a great sustained mental effort, he had substituted images mathematically proportioned that the first glance takes in and knows without fatigue, and which manifest immediately the natural consequences or the comparisons unforeseen. Fully convinced of the utility of these applications, he claimed their original conception with a certain pride. So one of the things that he produced, one of the diagrams he produced, really was an application of pie charts to cartography, a mixture of what Playfair had done and maps. And in this fine example from 1858, we see the number of animals sent from the French provinces to Paris for slaughter, averaged over the years 1845 to 53. Here the coding is black is beef, red is veal, and green is lamb. The colours are somewhat faded. And the scales given as 6 millimeters represents 330 tons. This is a totally different sort of diagram produced by Minard in 1865. At that time, a decision had been made to to build a new general post office in Paris, but where to site it? Well, what he did was he had a look at the populations of each of the arrondissements, the districts of Paris, and he represented those populations using squares correctly proportioned. And then he made a judgment as to where the new general post office should be sited by eye. We know him best probably for the visualization, his visualization diagrams of flow of one sort or another. And here's a fine example from 1844. It's the first sectional bar chart showing the movement of goods along the canal between Dijon and Chalon-sur-Saône. Fabulously detailed, wonderfully colored, showing directions, both directions. And of course, it's really a sectional histogram because the frequencies are represented by areas, not heights, though the word histogram, of course, was something that didn't come into the English language until it was introduced by Carl Pearson much later on. And here's a similar diagram in monochrome, a sectional bar chart from the following year, showing the movement of passengers by train between Dijon and Mulhouse. In fact, there were many train lines with different operators, different owners at the time. And when they saw this particular diagram, they drew diagrams to show what was happening on their own rails. But one disgruntled character realized that the original diagram was so effective that he produced a fake copy, depressing the figures for his own business advantage. I'm going to talk a little bit about Napoleon, because as we'll see, there's something rather special in Minard's work about Napoleon and his efforts to take Moscow. So if I was wanting to learn about Napoleon's march on Moscow and retreat from it, I might read Adam Zamoyski's book, a splendid book. Or, of course, I could read War and Peace. I have read War and Peace. I haven't actually read Adam Zamoyski's book. But the history runs to 672 pages, and the fictional version runs to 1329. There's an awful lot to take in, whether we're dealing with the more factual or with the version that Tolstoy imagined. But here's a single diagram showing the strength of Napoleon's army as it marched on Moscow and in retreat. It's one of those wow sort of diagrams. I'll let you take that in for a moment. See if you can picture what's going on, and I'll explain on the next slide. So here we are again. The thickness of the tan path indicates the number of men available to Napoleon, from over 400,000, and these figures do appear on this particular diagram, from over 400,000 at the outset of the campaign to just a quarter of that as he reached Moscow. Then the retreat along the darker path, with the number of men continuing to decline until only 10,000 remain as the army re-enters Poland. A catastrophic situation. But in this single diagram, Minard has 6 variables. The strength of the army, its position, latitude and longitude, 2 dimensions. The time, that's the 4th of the variables. The direction of movement, and the temperature, which is shown underneath. Remember that the temperature, the bitter cold, was a factor in the failure of this campaign. Edward Tufte, the historian of visual graphics, has commented that this may well be the best statistical graphic ever drawn. Minard was also keen to flag up the novel diagrams of others, such as Massicar's polar line graph, showing a railway company's weekly receipts from ticket sales. Here we see it in Minard's version. Note that successive weekly totals are joined by a straight line to give a sort of contour, and that each week is also partitioned into days. This diagram is not related to the pie chart because receipts are proportional to radial distance, not area. And now we move from France back into Britain in the middle of the 19th century for the third and final part of this talk. We start with William Farr, who was the first statistician at the General Register Office, where he was a key figure in the design of the 10-yearly census that we still have today. By trade, he was a doctor, epidemiologist, who believed the cholera was spread through the air and so was affected by the weather and by how close together people lived. And he produced this polar line graph relating temperature and cholera deaths. It relates to the problems, the cholera outbreak in the 1840s. It was published a few years later in 1852, but it shows the weekly deaths and temperature from 1840 to 1850, and also averages by week of the year from 1840 to 49. The black shading shows excess mortality over the expected number, something we've been hearing a lot about in recent times. And the yellow shows the opposite, a relative healthiness. Note the spike in deaths in the winter of 1847 and the late summer of 1849. But like the Massicart-Minard frequencies are proportional to radial distances, not area. And now we need to talk about Florence Nightingale's very famous polar area graph. And again, I'll have it up as large on your screen to begin with, so you can start to think about what it looks like and what features it has. But obviously I'll be looking at those details in just a moment. But let's start by talking about Florence Nightingale. She was born in 1820, lived to 1910, a long life and a hugely productive life. Florence Nightingale was born into a very wealthy family. And she was born whilst they were touring in Italy. In fact, Florence was born in Florence, hence her name, and her sister, Parthenope, was born in Naples on the same tour. So this is a long tour in Italy. Parthenope is a classical Greek name for Naples. I think Florence had the better of the two deals. The family had a Georgian mansion in Hampshire. It was not their only house. And Lord Palmerston, the Prime Minister during the Crimean War, was their neighbour. Politicians frequently visited the Nightingales. Florence was taught largely at home, excelling in languages, French, Italian, some German, plus a smattering of classical Greek and Latin. Her father was a graduate of Trinity College, Cambridge, and so taught her mathematics. And the likes of Charles Babbage, William Spottiswoode, who was later president of the Royal Society, were among many scientists who visited the Nightingales and with whom she had discussions. Let's have a look at her development in her thinking, what she wanted to do with her life, her movement towards statistics and nursing. In early adulthood, Florence had no idea what she wanted to do. But eventually she began to take an interest in public health and public health statistics. This was a time of emerging interest in statistics in Britain. The 1830s saw the birth of the Statistical Society, now the Royal Statistical Society, and also of the Statistical Society of the British Association for the Advancement of Science. The statistical studies of public health were being carried out by the likes of William Playfair and Edwin Chadwick, a Poor Law Commissioner, who later wrote the report on the sanitary conditions of the labouring population of Britain. This is Chadwick. Florence also read Adolphe Quetelet's treatise on man and his development and the development of his faculties, and later became familiar with his application of the normal curve to the measurement of man. Quetelet was an astronomer, aware of the error law, which is mathematically the same function as the normal distribution. And he applied that law to the chest girths of men and the heights of men. He was the first anthropomist. I won't try that. He measured man. In the late 20s, Florence visited hospitals in Rome to see the conditions. She was accompanied by Liz Herbert, a friend, but also the wife of Sidney Herbert, who was then in the cabinet. She spent almost 4 months near Dusseldorf, training as a Protestant institution for the sick and destitute, where saving souls was more important than saving lives. Florence took a slightly different view, although very devout herself. She was more concerned with the healing. And while she was there, she learned how the hospital was organized and operated. Now with a vocation, her father settled £300 a year on her. That's about £30,000 in current money. And she became superintendent of nursing at a small establishment for sick women in Harley Street. With the cholera outbreak in London in 1854, we've just been talking about it, she volunteered at the Middlesex Hospital. And by this time, she saw her future in the training of nurses. Britain and the Crimean War, 1853 to 56. I should say that I'm giving this talk the same day as Vladimir Putin has suggested that he'll be moving troops into Ukraine. Strange coincidence. In 1853, Russia recognized the fading strength of the Ottoman Empire, the Turks, and moved into what is now Romania. And the Ottomans declared war, knowing the French and the British would support them. Within months, the French and British navies had attacked Sevastopol, the home of the Russian Black Sea Fleet. Total losses over the course of the Crimean War possibly reached 500,000, including 40,000 British soldiers. This was a major, major conflict. This is Sevastopol. The injured at Balaclava, Inkerman, and Sevastopol were loaded onto boats and dispatched to Scutari and other hospitals not far from present-day Istanbul. And you see them in this, the lower picture here, a painting, getting into boats, small boats, for the hazardous crossing over the Black Sea. And here we see the coalition government of 1854 with Sidney Herbert, who was then Secretary at War. And this is Elizabeth Herbert, Florence Nightingale's friend. You can perhaps see where this is going. Sidney Herbert, and I assume Liz, identified Florence Nightingale as a suitable person to organise the army hospitals, and she was appointed by the government as superintendent of female nurses in the East. She arrived in November 1854 with 38 nurses. At the time, over 40% were dying of their wounds and poor treatment, but also from poor sanitation and disease. And in fact, probably more from the latter two than the former two. So Florence instituted a large-scale data gathering exercise, as well as new programs of hygiene. But the conclusion she came to from gathering the data was that our soldiers are enlisted to die in the barracks. And her findings were written up in a book of 1858 called Health of the British Army. The book included this iconic polar area graph, a diagram that had been used carelessly by William Playfair. Remember that he had frequencies proportional to radial distance instead of sector area. The year from April 1854, you see that at 9 o'clock on the diagram. The year was split into 30-degree sectors, one for each month, and they had different radii depending on the numbers dying. The outer blue-grey regions represent preventable deaths. After Nightingale's changes were implemented, preventable deaths fell dramatically. This is the next period in time from April 55 to March 56, the next 12 months effectively. And you can see that at the 9 o'clock position, which carries on immediately from the previous diagram, there are still some high figures rising a little bit further into late spring and early summer, probably because of the heat, and then fading very, very substantially, and then very, very quickly to almost none. When Florence Nightingale got back from the Crimea, she was asked by the Queen to come and see her at Balmoral. And there she explained what she had witnessed at Scutari, the measures she had implemented, the data she had gathered, and the diagrams that were coming from that data. Particularly important here is the fact that Albert was also in on these discussions. And Prince Albert was very forward-thinking. But not only that, he had been tutored by Adolphe Quetelet, the Belgian statistician and astronomer I was telling you about earlier. And so he knew, he had a feel for statistics. He knew how they worked. He knew how convincing they could be. And so with Victoria and Albert's support, and then the support of the parliamentarians, because she was still in touch with Palmerston, a neighbour, and others, Sidney Herbert and his wife, the Army Medical Board was reconstituted into 3 separate sections: medical, sanitary, and statistical. These had long-term effects. And Florence Nightingale once said that whenever I am infuriated, I revenge myself with a new diagram. Wonderful statement. And here we see Florence Nightingale and Sidney Herbert on neighbouring plinths at the Crimean War Memorial in Waterloo Place in London. Before I sum up, I'd like to show you 2 or 3 books. So the first one is from Edward Tufte. I mentioned Edward earlier. The Visual Display of Quantitative Information, from Graphics Press, 2001, was the definitive work on the subject of statistical diagrams. I would suggest, until this book was published very recently. A History of Data Visualization and Graphic Communication, written by Michael Friendly and Howard Weiner, Harvard University Press, and it's just out 2021. And in terms of biography, well, where better to start than a book by Bruce Berkowitz, Playfair, The True Story of the British Secret Agent Who Changed How We See the World. That's from George Mason University Press in Fairfax, Virginia, 2018. A good read, a long read, a detailed read. There are facsimiles of Playfair's two main books, the Commercial and Political Atlas and the Statistical Breviary. They have been edited by Howard Weiner and Ian Spence and are available, as of 2005, are available from Cambridge University Press. And if you want to learn about Florence Nightingale and her life, there is an excellent biography, again, rather new, comes from Mark Bostridge, Penguin paperback 2020. I need to sum up. So the main messages from this talk on statistical diagrams from William Playfair to Florence Nightingale. Firstly, statistical diagrams were first crafted by William Playfair at the end of the 18th century and the start of the 19th century. His favorite diagram was the time series chart, but he designed the bar chart as a moment in time snapshot when his data were inadequate. Playfair also gave us the pie chart, though he may have favored the annular or concentric circles chart. From the outset, all the features of a good statistical diagram were evident. His reason for using statistical diagrams is laudable, arguing that making an appeal to the eye when proportion and magnitude are concerned is the best and readiest method of conveying a distinct idea. Playfair's diagrams initially found much more favour in France than in Britain, perhaps because of his colourful life history. Charles-Joseph Minard developed a range of statistical diagrams concerned with the flow of goods and people. He gave us the sectional bar chart, a centre of gravity diagram, and superb multidimensional overviews of war campaigns. He also promoted the radial line graph, an inferior diagram that also found favour with William Farr in Britain. Interest in statistical diagrams in 19th century Britain arose out of concerns about poverty and public health. William Farr, a doctor in charge of the decennial census, Edwin Chadwick, a lawyer and poor law commissioner, and many others drew attention in words, data, and diagrams to the fact that change was needed, and their actions were supported, for example, by the writing of Charles Dickens. Florence Nightingale's polar area graph is stunning in its impact. She is remembered first and foremost as a nurse and nursing administrator, but her use of statistical diagrams had an almost immediate influence on policy and practice, influence that saved thousands of lives. Statistical diagrams are interesting in their own right, but each has a story of its own to tell. Thank you. Remember that the contact details are on this slide.